Hello dear students, in our earlier lectures we have discussed what are the chemical classification of matter, and you have seen on the basis of chemical classification the matter is categorized basically into two categories, that is the pure substances and mixtures, right? So today we'll have some more detailed idea about the mixtures. In order to understand the type of mixtures, let's have an activity. So let's have a group of say 3 students like group A and group B and group C. Group A is said to dissolve few crystals of say copper sulfate in water. Group B has dissolved say some amount of sugar in water, and here group C has taken what? Group C has taken a mixture of common salt, and copper sulfate and say potassium dichromate in solid state, right? So all the groups they mix their components thoroughly, they ensure. So if you look at the mixture of group A, in group A, as you know, copper sulfate is a blue colored compound, and when you dissolve this copper sulfate in water, what you observe, that whole of the solution develops a uniform blue color, right? So you will observe the solution to be blue colored, and this blue color is uniformly distributed. So you won't observe anywhere, or you cannot differentiate between here the particles of water and particles of copper sulfate. Say if you take the solution of group B, in group B which has dissolved sugar in water, and you will observe a colorless solution, and any part of the solution when you taste it, it gives you an equally sweet taste, right? But if you look at the mixture of group 3 or group C, that have added common salt as you know, which is white in color, copper sulfate is blue in color, and potassium dichromate is orange in color. Howsoever thoroughly they have mixed the components, if you look their mixture, you will be able to identify here particles of sodium chloride, means common salt, and copper sulfate, as well as potassium dichromate, right? So particles here are easily visible, they are easily distinguishable from each other. So in that case, the first two groups where you are getting the partition mixture of all the components. So here the first two are giving you a homogeneous mixture, and this homogeneous mixture is known as what? This homogeneous mixture is known as true solution, right? If we talk about the mixture obtained by group C, where all the 3 types of particles are easily identifiable from each other, then this results in formation of a mixture, that is heterogeneous mixture. So by this activity we can conclude that a mixture which is having a uniform composition of particles, where particles of different components are not separately identifiable, that results in formation of a homogeneous mixture, and the mixture where there is no uniform composition and the particles are easily identifiable, then it is known as heterogeneous mixture. So in our further discussion, today we will concentrate only on the homogeneous mixture, that is solution. So how can we define a solution? What is the solution? So the simple scientific definition of a solution can be given as that a solution is a homogeneous mixture of two or more components. So a homogeneous mixture of two or more components is known as true solution. And in every solution there are two components, and the two components of solution are solute and the another one is solvent. So solute is what? Solute is a component which is dissolved and present in a small amount, right? And what is a solvent? Solvent is the component in which solute is dissolved. So the component in which solute is dissolved and it is present in larger amount is known as solvent, right? For example, we have just discussed about the mixture of copper sulfate and water. So here you have seen that copper sulfate which we have added, which we have dissolved, is what? It is solute, but the water in which the copper sulfate was dissolved here is a solvent. Similarly, if you think about sugar in water or salt in water, so here sugar or salt are solute and water is solvent. Clear? Now, one thing, when we talk about solution, why you sometimes have that confusion that solution means something that is liquid in a state. It's not always true. Depending upon the physical states of solute and solvent, we can have different types of solution. You can have liquid solutions, you can have solid solutions, or you can have gaseous solution. For example, if we talk about liquid solution means the solution where solvent is liquid, but the solute may be solid or liquid or gas. Like for example, the examples we have just taken, the solution of copper sulfate in water or sugar in water or salt in water is the example of liquid solution where solute is a solid and solvent is liquid. You can take liquid to liquid solution. For example, alcohol added to water, right, is the example of liquid to liquid solution. Gas to liquid solution means, for example, you can talk about your aerated drinks, cold drinks that have dissolved carbon dioxide in them, and that is the example of gas in liquid solution, right? Similarly, you can have gaseous solution. So if we talk about gaseous solution, are the solution where solvent is a gas but solute can be a solid, liquid or gas, right? For example, if you talk about smoke, smoke is having unburnt solid carbon particles or dust particles suspended in air. So that is the example of solid to gas, right? Liquid or gas For example, there can be example of liquid to gas, and there may be the example of gas to gas. For example, if we talk about air, in air the solute is oxygen gas and the solvent is nitrogen gas. So it is an example of gaseous solution. Similarly, you can also take the example of solid solutions. When we talk about solid solutions, in solid solutions, the solute is a solid as well as solvent is also a solid, right? So here in this case we can take the example of alloys. Alloys are what? These are, you can say, these are the mixtures of metals or metal and non-metals. So alloys have got very important use in our daily life. There are so many alloys that we use, and you know, when two or more metals or non-metals are mixed to make an alloy, this is done in order to improve the properties of the metals, right? For example, the gold ornaments that we use is not a pure gold. It is basically an alloy of gold with copper and silver, because pure gold is very soft and not easily usable. So it is mixed with copper or silver to increase its strength so that it can be used, right? Similarly, the steel vessels that we use, the steel is also an example of alloy, which is basically containing iron, and this iron is mixed with a small amount of carbon or other substances like nickel or chromium, depending upon the type of steel we want. The reason is because iron gets easily corroded, but the steel that as an alloy is free of corrosion. That's why it is also known as stainless steel, right? So these are the various types of solutions. So if we look at the properties of solutions, so we to look at the properties of solutions. So here are some important properties of solution. Of course, first of all, as we have already discussed, that it is a homogeneous mixture, right? Another important property here is that particle size is extremely small. It is less than 1 nanometer. 1 nanometer means, you know what is the nanometer? You can say 1 nanometer is equal to 10 raised to power minus 9 meter, right? As particle is very small here, so you can say the particles are not visible to naked eyes or even under a microscope. We cannot identify the particles separately here, right? Then another important property in case of solution, that is, it is not filterable. Means you cannot separate the solute and solvent just by the simple process of filtration. Another important property here in case of solution is that the solution are highly stable. Stable in the sense that if you prepare some solution, for example, you are having a solution of sugar and water, and if you leave it undisturbed for some time, you don't observe any sugar getting settled down, right? That's why we say that solutions are stable. And of course, solutions do not scatter the beam of light So suppose here you have a solution of something, say sugar in water or salt in water or anything else, and if you pass a beam of light through this with the help of a torch, you observe that this beam of light comes out, and here in solution the path of light is not visible to you, right? So that is another important property of solutions, right? So here are some common properties. It is a homogeneous mixture. Particle size is very small, less than 1 nanometer. Particles are not visible to naked eyes. Not filterable. Stable, particles do not settle down, and it does not scatter the beam of light passing through it. There are so many common examples of solutions that we use in our everyday life. For example, you must have heard about tincture of iodine. Tincture of iodine is what? It is a solution of iodine in alcohol and used as an antiseptic when you have got some cut or wound, that this tincture of iodine is applied. Another example of solution is air. Air, as it contains the various gases like oxygen, nitrogen, carbon dioxide, etc. And this air is responsible for sustaining the life on earth, right? So many examples of solutions we observe in our everyday life that make our life simple and easier, right? So that was an introductory idea about solution. How to express the concentration of solution, that we will be discussing in our next lecture. Have a nice time. Goodbye till then.